Good evening, everyone. So welcome to my YouTube channel, Math Spectrum. So today we are going to see first lecture on graph theory. Okay. So let's start today's session now. So today we'll see what is the definition of graph. Okay. And its example. So what is graph? A graph G consists of two things. First one is that V is equal to VG. Okay. Whose elements are called vertices points or nodes of G. Okay. Second one is that E is equal to EG. It is denoted by E is equal to EG. That is subset of B cross B. Okay. B cross B of unordered okay. So a set, second one, a set E is equal to EG, subset of B cross B of unordered pairs of okay, unordered pairs of vertices of G. Okay. So we are writing V cross B. We know that V cross is actually ordered paired element, but somehow we are saying that this is subset of it, but we are taking unordered pair. Okay. We denote graph by G, V, E or G is equal to V. Okay. So what are the examples of graphs? Example 1. Let V is equal to 1, 2, 3, okay, and E is equal to 1, 2, 1, 3, okay. Now see that E is subset of V cross V, okay, and E is unordered, okay. Now, how to draw graph of V? So, G is equal to VE is a graph. How to draw graph? So, what is the pictorial representation of this graph? Okay. So, we have graph, the nodes of or the vertices of graph are denoted by those dots, okay. So, this is 1, this is 2, and this is, okay. So, we have A's. So, we have A's. A's is denoted by E1. So, we have 1, 2. 1, 2 is A's. 1, 2 is means the A's connecting 1 and 2. And E2 is 1, 3. The A's connecting 1 and 3. Okay. So, how to write? You can join the graph by this way, or you can join by a straight line also. You can use a straight line. Okay. To join the nodes of a graph, you can join a curved line, or you can join by straight line. Okay. You can join the curved line by curved line. Okay. So this is a straight line and this is a curved line. So this is E1 and this is E2. Okay. So example 2. Example 2. So V equal to A, B, C, D and E is equal to A, C, A, D and B, C. So V is subset of V cross B. So G is equal to VE is a graph. So how to draw this picture? What is the picture of G? So by node, I already told that node are denoted by points. So AC is connected with E. So AC is connected with C. Let's connect A with C. And A is connected with D. A is connected with D. So we can use either straight line or curve. Okay. Now B is connected with C. B is connected with C. So this is the representation of graph by pictorial. So E1 is here. E1 is AC, you can say. E2 is AD and E3 is equal to PC. Okay. E1, E2, E3. Okay. So what are the adjacent vertices? Okay. Vertices U and V are said to be adjacent or neighbor to each other in a graph G is equal to VE if there is an edge E belongs to E connecting U and V. If there is an edge connecting U and V, vertex U and V, then U and V are called adjacent vertices. Okay. In this case, U and V are called endpoints of E. Okay. Also the edge E is said to be incident on U and V. Okay. Okay. So in example first, we have given this. Example first was this one. So 1, 2, 3. Example first was this one. So what is So E1 is this, E2 is this. So E1 connects 1 and 2. So this implies 1 and 2 are adjacent. E3 connects 1 and 3. So this implies 1 and 3 are adjacent. Okay. Okay. E1 is incidented on 1 and 2. E2. This is E2 here. E2 is incidented on 1 and 3. Okay. So I would like to write here E1 is incident E1 incident on 1 and 2. E2 incident on 1 and 3. So example 2, what was that? It was A, B, C and D. Okay. So A was connected with and this was connected with and B was connected to C. Let me see again. Okay. B was connected with C. So this was E1, E2, E3. Okay. So E1 connects A and B. So this implies A and B are adjacent. E2 connects A and D. So this implies A and D are adjacent. Okay. E3 connects B and C. This implies B and C are adjacent. Okay. Now, E1 incident on 1 and 2, sorry, A and B. Because what are the endpoints of E1? 1 and 2. So E1 incident on 1 and 2. E2 incident on 1 and, sorry, E1 incident on A and B. Okay. E3 incident on incident on B and C. Because E1 incident on A and B, because E1 incident on A and B, because the A and B are endpoints of E1. E2 is incident on A and B because A and D are endpoints of E2. B and C incident on E3 because B and C are endpoints of E3. Okay. Isolated vertex. Let G is equal to PE, PA graph. Then a vertex B belongs to B is said to be isolated if there is no case B belongs to E which connects B with other vertex. There is no ace in B which connects B. Okay. For example, you see this. You see example there. B is equal to A, B, C. And you take aces E is equal to AB. Then E is subset of B cross B. So what is the graph of G? So graph of G. So G is equal to V is a graph. So you take. So what is the graph of this? What is the pictorial notation representation of this graph? So this is A. So this is connected. So there is no ace in this graph which connects C. So C is isolated one. Sorry, isolated vertex. C is isolated vertex. As there is no graph connecting as there is no ace connecting C. Okay. Okay. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. We will see you next lecture.